Comfort is a function of temperature and freshness, the lightness of the air. So if it's stale, people are very uncomfortable. If the air's too hot, too cold, they're very uncomfortable. And so this tempering the air so it's closer to the room temperature as it's coming in and bringing it in as 100% outside fresh air filtered. It's also filtered, of course. That provides both a better temperature distribution and that lively, fresh air feeling, and removes the CO2, which is another big effect on health as well as productivity. We see commonly used what's called a rooftop unit. It's a packaged rooftop system of heating, cooling, and ventilation all in one box. This has been the way of building mechanical systems on rooftops for many, many years. And that has served its need, but it's not the most efficient system. So when thinking about designing a heating, ventilating, air conditioning system, first, of course, it depends on whether you're designing a new building, or you're working with a retrofit or an upgrade or a modernization of an existing building, or you're just simply replacing the equipment, the old equipment that's already on there. So say if it's greater than 7, 8 years old, in the 10-year range, that's a good time to think about replacement. The VHE DOAS system applies in all of those situations. So VHE DOAS, very high efficiency, dedicated outside air systems. It's a heating, ventilating, and air conditioning system. And what that means is that you've separated the ventilation air from the heating and cooling air streams. In the very high efficiency system, it's treated through, it's conditioned through a heat recovery ventilator. The heat recovery ventilator leverages the extra heat that's in the air of the space as it's being exhausted and captures it and transfers it through a heat exchanger into the fresh air that's coming into the space. And it's using less air for the distribution of that heat into the space. It's just the air that it needs for heat or cool distribution, not ventilation. And the planning phase is before you really get into sort of design. You're not really sizing anything. You're just saying, okay, we have a goal. We have a target. We have an energy efficiency target of X, or we have a EUI target of some number Y. Then you move into the conceptual phase where you're sort of thinking about the overall layout of maybe the system and ducting, and then you move into schematic design. This is in a more traditional sequence of design. And at schematic design, you're probably starting to size. You're actually sizing your system. So it's really important to think in an integrated fashion. So you have to size your HVAC in relation compatible to and in relation to the heat from the lighting, the people, the heat gain through windows. But it's important to involve the local utility early because they may have incentives available to help offset some of that cost. Or one of the main benefits of this system is providing fresh air to the space to help enliven the space and keep people, happy and productive and comfortable.